Today we'll be diving into the dynamics of a cello. In particular, the forces, reactions, and moments that are all necessary to correctly play a cello. This is the free body diagram of the cross-sectional view of the string. F of A in the Y direction, the downward force applied by the player acts on the string. The string exerts a normal force N upward on the bow. The force of friction at contact point C is caused by the bow pulling the string to the right. This results in an acceleration of the string to the right. There are two assumptions made in this example. First, the bow will always be pulled in the same way, so F of A in the X and F of A in the Y remain constant. Second, gravitational acceleration is negligible compared to the force exerted by the player. The player gets the proper sound from the instrument by deflecting the string to the side, as seen in the video. The displacement of the string is caused by the force of friction acting at contact point C. Friction accelerates the string to the right, causing it to deflect and produce a sound. When the force of friction between the bow and the string is too small, the string will slip. This means there will be no acceleration of the string and an undesirable sound will be produced. The force of friction depends on the coefficient of friction and the normal force. This implies that the poor sound quality is a result of the decrease in normal force that is proportional to the decrease in downward force at point C. Overall, the goal is to always have the same force of friction at point C, so the sound of the string is consistent. If the player wants to always have the same normal force, they have to consistently create the same downward force at point C. This view shows a free body diagram of the bow. When the player's hand is directly above contact point C, there is no distance between their hand and the string. Therefore, the normal force the string exerts on the bow will be the same as the force the player's hand exerts in the Y direction. When contact point C is in the middle of the bow, the player must exert a moment on the bow to get the same normal force from the string. This is because there is now a distance between F of A and the Y and the contact point. When contact point C is at the end of the bow, there is now a distance of 2 feet between F of A and the Y and the contact point. Therefore, the player must exert an even bigger moment on the bow to get the same normal force and the same force of friction and the same sound. Dynamics plays an important role in the sound quality of a cello and shows how everyday activities rely on the principles and laws of dynamics.